Hello everyone, my name is Luiz Moro Rosso and I'm a master's student working with the CMPD's lab. The goal of this video is to introduce and give a little bit more details on the R package we have recently released in Chrome, the XPolaris. The video will be divided in three sections. First, I'm going to talk about the Polaris database itself, how it was created and what variables are there. Then, I'm going to show you the Harvard Dataverse repository, where we have a coding tutorial and a code example, and we are going to run the code together in our studio. And for the third section, I'm going to show you the Git-Hub Repository, where we have the development version of the package. There, you can have access to the functions to see how they work in the background, and you might also be able to contribute with future versions of the package. So, thanks for your attention, and let's get started. I'm going to show three publications I consider to be extremely important if you are going to work with the Polaris data. The first one was done by Nathan Odgers et al. In 2014. And here they created a machine learning algorithm called disaggregation and harmonization of soil map units through resample classification trees, the D-SMART. This algorithm was able to predict the probability of occurrence of different soil classes in a region of Australia, and it was used in the Polaris database later on. In 2016, Nathaniel Shani et al., they published the Polaris database for the first time, the idea of Polaris, and they explain how the soil survey geographic database, the Surgo, was used as the baseline for creating Polaris. But Polaris was able to fix some issues of Surgo. For example, here we can see clear how Polaris was filling some spatial gaps of Surgo. And then the most recent publication done by Shani et al. In 2019 is interesting because it's talking about all the variables, the 13 variables present in the database, the range they have in the United States territory, the units, we have sand, silt, clay, organic matter, and other hydrological properties. And they also show how the soil layers were created, how they were estimated. And it's interesting because they also talk a lot about Polaris being a probabilistic soil series map, so it does not estimate a single value for a coordinate for a geographical location, but it actually estimates a distribution of values. This distribution was then summarized by the mean, the median, or the mode for the final Polaris database, but it's not a point estimate. In the publication, they also have a summary of all the variables in the United States territory. For example, you have the distribution, the geographical distribution of sand, silt, clay. So it's a very interesting summary. And the summary of this distribution, such as the mean, median, mode, are presented in a database hosted in the Duke University from North Carolina. If you open this database, you have a folder for each one of the variables, and then let's say we are interested on clay. Inside of the clay folder, we have the mean, mode, the median, or the 5th and 95th percentiles. If you open, for example, the median, you will see that we have the different soil layers then, 0 to 5, 5 to 15 centimeters, and so on. Let's say we are interested on the 0 to 5 centimeters. If we open that folder, then we have TIFF images, raster images. These raster images, they store the data from a 1-by-1 latitude, longitude coordinates. If you download one of these images, you can then extract the soil information for any geographical location. You will see that in this folder, you have a lot of images because they cover the entire United States, the contiguous United States territory. So you can imagine that if you want to download several locations or several soil variables or different layers, you could spend a lot of time looking for specific images and downloading each one of them in your computer. And also, if you want to download all the images, that would take a lot of space and a lot of time, depending on your internet connection. So that's the reason why we created the XPolaris package, to help users download the images they really need for some specific locations and soil variables. And that's what I'm going to show you next. This is a Harvard Dataverse repository called Retrieving Polaris Data Using R Software, and here is the citation for the repository. We have here a set of example locations in Kansas, saved as a CSV file, and then we have a code written in R Markdown. We have the package documentation with the function arguments and some instructions regarding the functions. And then we have a code tutorial that is basically all the usage instructions, some details about the functions and how to work with them. If you download this PDF file, you can see the tutorial here. And so let's go through the document quickly. So XPolaris was released in Chrome in June of 2021. And here is how you install and how you load the package. Then we talk about the X-Kansas locations, which is a data frame that comes with the package when you load it. The X-Kansas can be saved, can be stored in any object. For example, here we are saving it in the df.lock. And here is how it looks like. You have the ID, which must be a unique identifier. They cannot repeat for different locations. You have the lat and long columns that must be decimal degrees for both of them. And then we have only 3 functions in the package. The first one of them is called xplot, and it takes as arguments locations, which is a data frame, and the local path where you're going to store the images, where you're going to store this plot, where you're going to store the data in a CSV format at the end. So if you inform these two, the function will save the image in a new file in your working directory, and we are using the get working directory here, but you can specify any path. And here the red squares are showing the images in the Polaris database I have shown before, where your locations fall. So basically the 3 locations we had in the X-Kansas example, they fall in those 2 squares, in those 2 images. And then the second function of the package is the most important one, because here, besides the locations data frame and besides the local path, the user will tell which variables he wants, which statistics, summary statistics of the Polaris distribution estimate, and which layers, soil layers he wants. So in this example, the user is interested in pH, organic matter, clay, silt, sand. He wants the mean of those variables, and he wants the 0 to 5, 5 to 15, and 15 to 30 centimeters. So the important point here is to make sure the codes, for example, pH, must be written in lowercase letters, because this is the way the paths to the online Polaris directory are composed. So they must be written the same way they appear here in the table 1 of the tutorial. And here is the final output units. The last function of the XPolaris package is called XSoil. Here we take the output from the XImages functions, which we saved as df.out, and we pass that as the main argument of the XSoil, just because it has all the paths to the images already there. So the XSoil will access those images in the user machine once they are downloaded, and we'll create a table object. This table object has different columns, but it has one column for each soil variable the user requested, for each ID, for each lat long coordinate, and for each soil layer, and the summary statistics of the distribution, which was the mean in this case. And here are the references for the papers we have discussed before in this video. So now let's move to the package documentation. I'm not getting into details on the package documentation, but here you have access to the description of the function arguments for X images, for the XPlot, and for the XSoil function. And you can access this help or this information also in R if you type the question mark and then the name of the function. For example, question mark XSoil in your R or RStudio, and then that will display the help for the function. Here is the XKansas CSV file that is in the Harvard Dataverse repository, and users can take this as an example to create their own set of geographical locations, always making sure the IDs are unique for each latitude, longitude coordinate. And then, so here is the code example written in R Markdown, and this is RStudio. Here we can run this code together. So let's get started. So we started by loading the package. If you don't have the XPolaris package installed yet, you can unlock this line number 15 and then run the install package function. Then we assign the XKansas object to the df.lock object. And then we run here the XPlot function. So we pass the df.lock as the argument for locations, and then we set the local path as the get working directory. Right now, if you check your current working directory, you have a new folder there called Polaris out, where you have this plot and where you will have soon the images you downloaded. And at the end, you also have a CSV file with all the soil data. So this, as I talked before, you have the red square as a way of checking if your locations are falling in the right places. Then the most important function here, we specify here, just because it's an example, we are only retrieving the pH. We are wanting the mean, and we want the 0 to 5 centimeters layer. And we are also storing the images in the working directory. I have run the function before in advance, so we can move faster in the video, but you will see here in the console that the images are going to be downloaded, and it might take some time depending on your internet connection. Once the images are downloaded for a specific set of variables, you can run the function again, but the code will not download the images twice, just saving the time of the user. And then here you can just unlock another variable, and the code will run and will retrieve the data for all of those variables. And then the last function is, it just takes the df out, which is the output from the X-images file, as the input for the XSoil. Because this df out object, if we open it, we will see that we have the local file where the images are stored, and then we have some more information about the images, and we have the coordinates that we want to retrieve for each specific raster image. So if you run the XSoil function, you have a table object, sorry, and then you have here, we only requested the layer 0 to 5 centimeters, and then you have Scandia, Bellevue, and Ottawa. You have the locations, and then you have the pH value, the mean for those 3 locations. And this is the final output and the final outcome from the XPolaris package using the XSoil function. So now, since you already know how to use the package, I'm going to show a little bit more about the development version in GitHub. The XPolaris retrieving soil data from Polaris was recently released in the Git-Hub Repository under the version 1.0.1. And in this web page from Cron, you can access the package manual and the source files of the package. But in the GitHub repository, you have access to the development version of the package, where we might improve the functions or add new features in the future. Here you have a README file with a short description, instructions on how to install the package. You have an example, the example locations in Kansas, how to access it. You have more instructions on the three package functions, xplot, ximages, and xsoil, as I already presented in the coding tutorial from the Harvard Dataverse repository. Here you have a table with the variable codes, you have the statistic codes, you have the soil layer codes. If you open the R file, you can have access to the function background, to the R code creating those functions. So if we open, for instance, the ximages file, we will see how the code is making sure just a minimum number of images will be downloaded for a set of geographical locations. We are going to see also how those images are downloaded, how the path to store the images, and how the path to access the images in the online Polaris database is created. And then also how the code makes sure that once the images are downloaded in the user machine under a certain path, if you run the function again, the images will not be downloaded twice, repeatedly. So just saving time and saving time from the users. If you look at another example, let's say the xsoil function, you will see how we access the images in the user's machine and how we extract the soil information from the images for each specific location, each point coordinate, and how we save that as a CSV file under the new directory called Polaris out. And we also have the xplot function, how we create that image just to check if the locations are in the right images, are placed in the right images. So this is the development version of the package. We hope this tool is useful for researchers looking for soil data in the United States. And we will be glad to respond to any questions, or if you have any issues using the package, just report here in our GitHub repository or get in contact with us. So thank you very much for your attention, and we hope this tool is useful for you. Thank you very much.